Hello everyone. In this session we are going to discuss about the inverting and non-inverting configuration of op-amp, and here in this what we are going to actually discuss is the voltage, output voltage, and the gain of inverting and non-inverting amplifier. So let us start with our session. So here in this circuit, as we can see that this is inverting amplifier. Why it is called inverting amplifier? Because the input is provided to the inverting pin of the op-amp, that is pin number 2. So as you can see over here that it is being, let me show you by drawing. So might be it is not available here. So what we can see here is the pin number 2 is on this place, okay, at the inverting pin. So this pin is pin number 2, and the voltage at this node, let us it be V2, okay, because this voltage is at pin number 2. So you can name it whatever you want, but I have purposely named it as V2, as it is the voltage what we get at the node 2 or pin number 2. Okay, so now again a note point is that it is a negative feedback amplifier, as feedback is presented, as you can see that feedback is presented between, or it is present between this output node and the input. See, the output and input are connected, so feedback is given from output towards the input, and hence it is called a feedback amplifier. Okay, now as we are providing the voltage V in to pin number 2, so and the feedback path is also there, so let us call the current that will flow from this V in B I1. So I1 is, I have marked here the current as I1 that will flow through this R1. Okay, now to this feedback path, the current that will flow, I'll call that current as IF, because it is flowing through the resistance RF, that is the feedback resistance. F for feedback, R for resistance, so feedback resistance. So the current, I marked it as IF, so it is just a notation. You can use any notation, it can be I1, I2 also, but please remember that purposely I have written here IF, that indicates that this current will flow through the feedback path. Okay, now we have to mark the output voltage as VOO and the dual power supply plus VCC and minus VEE. Now as the Vin voltage, input voltage is provided, the current will flow. Okay, so that is the current I1. Now as we know that, so the current flowing into the input terminals of op-amp, that is pin number 2 and pin number 3 towards the op-amp is 0. Why it is 0? Because input impedance of the op-amp is very much high. We have already seen this in our previous slides. So the current will not go into its input terminal, rather it will flow towards the feedback path. So when the current is flowing towards the feedback path, the currents, as the current is not changing, yes, but for the derivation purpose, I'll call that current as IF. Okay, that is the feedback current. So as you can see over here, I2 is present. I have also given the direction, because whenever the current flow, and if it has a node in between where there are two branches that are getting distributed, the current will get distributed in both the branch. So I have marked it as I2 and IF. But due to high input impedance, this I2 in the equation will get equal to 0. Okay, so I1 gets equals to 0. So see that what will be our I1? I need to find the value of I1, IF and I2. So how we can calculate? Now we have to apply the KCL at node 2. So KCL at node 2 means what? What will happen? The incoming current will be equals to outgoing current. So here towards this node 2, what can you see that what all different currents are coming towards this node 2 is only I1. Now current that is going away from this node are I2 and IF. So how the equation will be? I1, that is incoming current, is equal to outgoing, that is I2 plus IF. So for a while I'll call this current going into the input terminal equals to I2, even though there is no current as such going into it, but still for the purpose of explanation I have marked it as I2. So what is the final equation? I1 equals to I2 plus IF. Now what is I1? This current is flowing between two voltages. Okay, so we have to take into account these two voltages. So what it will be? It is Vin minus V2 upon R1. This will give me the value of this current. Okay, I equals V by R, but here as this resistor is connected between two voltages, so it will be Vn minus V2 upon R1. So this is what the incoming current I1 equals to I2 plus IF. So I2 equals to 0, we will be directly substituting it. I2 equals to 0. And now what will be IF? IF is again RF is connected between two voltage node, that is V2 and VO. So the current IF will be equals to V2 minus VO upon RF. It is what? V2 minus VO upon RF. Why we have not considered it as VO minus V2 by RF? Because current, the direction of current from where it is flowing will be treated as the maximum potential, and current always flows from higher potential towards the lower potential, and hence I have taken it IF current to be as V2 minus VO upon RF. So what our equation will now becomes? So it will be what? See, I1 we have written, IF we have written, we have this equation. I told you that I2 is equals to 0 and I1 is what? I1 was Vn minus V2 upon R1. This is our I1, and IF is what? V2 minus VO by RF. So now due to virtual ground concept, V2 is considered to be at same potential as that of V1. So what here I wanted to explain is, as here in this diagram V1 is connected to ground, and in the virtual ground concept I have already explained you that V1 dominates V2. So whatever is the potential at V1, V2 follows that potential. So as V1 is grounded, V2 has to follow that voltage. So V2 physically, as even though it is not connected to ground, but virtually it is assumed to be at the same potential as that of V1. This is what the virtual ground concept is. So we will mark in the equation the value of V2 to be equals to 0. Okay. So here this is our equation, and here we are now going to substitute the value of V2 as 0. Okay. So now by substituting V2 equals to 0, the right RHS will be minus VO by RF, and this LHS will be Vn by R1. So it will be Vn by R1 because V2 here we have substituted to 0. Now by rearranging this formulae, we can get this value of output voltage equals to minus RF by R1 into Vn. Okay, so this RF will go by cross multiplication, this R1 will come in front, this VO will go right hand side, and hence it will be minus RF by R1 into Vn. So what will be the formula? So this is the output voltage, this upper block will be the output voltage. Now what is the value of gain here? So gain is equal to output by input, and the gain of inverting amplifier is minus RF by R1. So many times the problem will be asked onto this formula to calculate the value of output voltage and the gain for inverting and non-inverting configuration. Okay. So just by substituting, if you know these formulas, just by substituting you can be able to get the correct answer. Now one important thing that I want to tell you is the output will never go beyond the voltage, maximum VCC and VEE voltage that we are applying. So if in the question, by substituting the proper value, given value, if your output voltage comes above the value of the VCC that you are going to provide as a dual to the dual power supply, your answer will get wrong. So actually, even though it is correct, there you need to write the explanation that the output voltage never goes beyond the supply voltage. So thank you once again.